Step outside tonight. Look up. If you are somewhere far from city lights, you can see roughly 2,000 stars with your naked eye. 2,000 points of light hanging there, silent, doing nothing. Just sitting in the dark, like they have been sitting there your entire life, and your parents' entire lives, and their parents' lives before that. You probably know, somewhere in the back of your mind, that those stars are not eternal, that they will die one day. But knowing something and feeling it are two entirely different things. Here is what you do not feel when you look up. Those stars are burning through their fuel right now, at this moment. And the universe is slowly but absolutely certainly running out of them. Not slowly in the way a candle burns down, slowly in the way a mountain erodes. We are talking about timescales so large that the human brain cannot genuinely hold them. We use the numbers, we say the words, but nothing in our experience has prepared us to actually understand what a trillion years feels like. It feels like nothing, because nothing alive has ever been there to feel it. The sun has been burning for about 4.6 billion years. It has roughly another 5 billion years left before it swells into a red giant and swallows everything you have ever loved at the planetary level. That already sounds like forever. It is not even close to the story we are about to tell. The universe right now, 13.8 billion years after the Big Bang, is in what cosmologists call the stelliferous era. That word means star-bearing. We live in the era of stars. Right now, the observable universe contains something in the range of 2 trillion galaxies, each holding hundreds of billions of stars. The sky is lit. The universe is warm, relatively speaking. There is light everywhere. And here is the thing no one really sits with. This era ends, not in a catastrophe, not in an explosion, not in some dramatic final moment where everything collapses at once. It ends slowly, quietly, in the way that a fire dies when it has no more wood. Star formation is already slowing down. The rate at which the universe creates new stars has been declining for the last 10 billion years. We passed the peak long ago. We are already on the downward slope. In roughly 100 trillion years, that is a 1 followed by 14 zeros, the last star will exhaust its fuel. It will cool, it will dim, and then it will go out. And what follows that moment is so vast, so silent, so completely beyond anything humans have words for, that most people never think about it. You should think about it. Because what comes after the last star dies is not just darkness. It is a duration of time so long that the entire history of the universe, from the Big Bang all the way to that last dying star, will look like the opening fraction of a single second compared to what comes next. And something strange happens when you really sit with that, when you stop running from it and actually look. Let us start with what we know. Let us start with something you can almost hold in your mind. The sun is a medium-sized star. Not remarkable, not especially large, just ordinary. It burns through about 600 million tons of hydrogen every single second. Every second. And even at that rate, it has enough fuel to burn for another 5 billion years. That is how much hydrogen there is in a star. That is how large these objects are. But the sun is not the last star to go out. The last star to go out will be a red dwarf. Red dwarfs are the dim, cool, miserly members of the stellar family. They burn so slowly, so carefully, that a red dwarf with about 8% of the sun's mass can burn for roughly 10 trillion years. To put that in perspective, our sun has been burning for 4.6 billion years, and the universe itself is only 13.8 billion years old. A red dwarf born today would still be burning 10 trillion years from now. It would outlive everything. Every civilization that will ever exist in this universe has a hard deadline set by these quiet little stars. Yet when the last red dwarf finally exhausts its fuel, it will not explode. It will not go out with drama. It will simply cool. Over billions of years, it will fade from dim red to invisible infrared, and then to black. A cold, dark sphere, drifting through empty space with no light, no heat, no radiation of any consequence. That moment is the end of the stelliferous era. But here is the gut punch. That moment, that end of all stars, that total extinction of every light source in the universe. It is not close to the end of time. It is not even a significant fraction of the way through. The universe after the last star dies will go on for incomparably longer than the universe before it. Think of it this way. If you took the entire history of the universe from the Big Bang to the death of the last red dwarf, all 100 trillion years of it, and you compressed it into 1 second, then what follows would last for something like 10 million trillion years. That comparison does not even work properly because the numbers break the analogy. The remaining time is not just longer. It is longer in a way that makes longer stop meaning anything. What exists in that darkness? For the first stretch, which cosmologists call the degenerate era, the universe is populated by the cooling corpses of dead stars. White dwarfs, the collapsed cores of medium stars like our sun, drift through space, cooling toward absolute zero. They are still there. They are still something. But they produce no light. They produce no warmth. They are just mass, slowly, incomprehensibly slowly, radiating away the last of their heat into a universe that is growing colder and emptier with every passing eon. There are also neutron stars, the crushed remnants of more massive stars, objects so dense that a teaspoon of their material would weigh about 1 billion tons here on Earth. 1 billion tons in a teaspoon. These objects also drift and cool, contributing nothing to the light of the universe. Eventually, current physics predicts that even the protons in ordinary matter will decay. The time scale for this is about 10 to the power of 40 years, a number so large that writing it out numerically would require more zeros than there are atoms in the observable universe. But if protons decay, then the white dwarfs and neutron stars and every rocky planet and every grain of dust will eventually dissolve, atom by atom, into radiation and lighter particles. The universe will literally come apart at the level of matter itself. After that comes what is called the black hole era. Black holes are the only large-scale structures left. Everything else is gone. And here is a strange and quietly beautiful fact about black holes. They are not truly permanent either. Stephen Hawking showed theoretically that black holes very slowly emit radiation, particles that escape from just outside the event horizon due to quantum effects. This radiation carries energy away from the black hole. Over time, the black hole loses mass. It shrinks. And eventually, after a duration that for a supermassive black hole runs to something like 10 to the power of 100 years, it evaporates completely. The last black hole will evaporate. And then there will be nothing. No stars, no planets, no black holes, no matter of any kind. Just a sparse, cold, almost perfectly uniform gas of photons and other fundamental particles spread across a universe that is unimaginably larger than the one we live in, because space itself has been expanding this whole time. That state, the physicists call it the dark era, will simply continue forever. There is no known mechanism to end it. There is no next chapter. There is just cold, dark, silent, empty space, expanding forever, with particles too spread apart to ever interact with each other in any meaningful way again. This is not a theory about some distant catastrophe. This is the well-supported prediction of our best current physics. And knowing all that, here is the question that should keep you awake at night. In all that silence, in all that unimaginable darkness after the last star dies, will anything know that it happened? Here is where the science stops and something harder begins. You exist at a specific moment, right now, on this particular night, on this particular planet, orbiting this particular star in this particular galaxy, in the first 0.1% of the stelliferous era. You are not just an observer of the universe. You are a feature of its current state. You are made of atoms forged in stars that died before the sun was born. The iron in your blood was manufactured in the core of a massive star that exploded billions of years before the Earth existed. You are, in the most literal sense, something the universe did with its matter during the age of stars. And the age of stars is finite. That is not a poetic claim. That is a fact of physics. The fuel runs out. The lights go out. And the universe moves on into eras of such profound emptiness that even the word emptiness does not do them justice. Most of us sense this, vaguely, and then we look away. We are busy. There is something on our phones. There is dinner to think about. There is tomorrow, which feels more real and more urgent than 10 trillion years from now. The scale is too large for our nervous systems to genuinely care about, even when our intellects understand it clearly. But there is something that happens when you refuse to look away, when you actually hold the fact that the universe is running down, not metaphorically, not philosophically, but physically, literally running out of the conditions that allow complexity and warmth and light. You start to look at the current moment differently. The star you walked past this morning on your way to somewhere is not a fixture. It is an event. It is a temporary burning, a brief ignition, a moment in which matter happens to be arranged in a way that generates heat and light and the possibility of chemistry. This moment, not just your life, but the entire era of stars, the entire epoch in which the universe is warm enough and lit enough for anything like life to exist, is not the default state of the universe. It is an exception. A brief, improbable, a luminous exception, surrounded on all sides by cold and dark and silence. The universe does not care about that. It has no preference. It will move with perfect indifference through every era, from the roaring birth of stars to the quiet evaporation of the last black hole, and it will not notice. It will not mourn. There will be no record kept, no memory preserved, no acknowledgement that any of this ever happened, unless something alive, something conscious, something like you, holds it for a moment. That is not a comfort, exactly. But it is something. We tend to make the universe smaller in our minds because the real scale is too destabilizing to sit with comfortably. We make it something to study rather than something to inhabit. But the numbers are real. The 100 trillion years are real. The black hole eras and the dark eras are real. And you are real right now, made of star material, looking back up at the sky from inside the only moment the universe will ever have that looks even remotely like this one. The philosopher in you wants to ask, if the universe ends in silence, did any of it matter? The physicist in you knows the question cannot be answered from inside the system. Matter does not care whether it matters. Black holes do not mourn the stars they once were. Photons drifting through an empty, cold, post-stellar universe do not remember when there were worlds. But you do. You are the universe's way of knowing it had a stelliferous era at all. And one day, after the last red dwarf dims, after the last white dwarf cools, and after the last black hole sighs out its final particle of Hawking radiation into the permanent dark, no one will know that any star ever burned. Except that right now, tonight, you do.